Alrighty, let's go right ahead and move along with number 27. So the question asks, solve the following inequalities, graph the solution set, and write the solution set in interval notation. So let's start with A. The idea here is you want to solve it similar how you would an equation. So if we have A, -4 is less than or equal to this -2/3 p plus 14. You want to move all the constants to one side and have everything attached to a variable on the other side. So I'm going to move this 14 over. -18 is less than or equal to this -2/3 p. And now I want that p by itself, so I'm going to divide through by -2/3. And when you divide through by a fraction, it is the same as multiplying by its reciprocal. So on that left side, I will have, also, since you are dividing by a negative, you're going to switch the sign. So we will get p is less than or equal to a positive 27. So p is less than or equal to a positive 27. And then if we want to graph the solution set, we're going to throw 27 on here. And it is a filled in circle or a bracket. And it is everything to the left of that. So our solution is anything less than or equal to 27. All right, now for the next one, similar idea. You're going to have y over 6 greater than 2 plus y over 3 minus y 1 over 4. Now, to get rid of these fractions, to make it look a little easier, you can clear through by a common denominator or by a common multiple of all three of the numbers there. So a number that we could do is 12, since 12 is a common multiple of 6, 3, and 4. And so if we multiply this 12 by y over 6 greater than 12 times 2 plus y over 3 minus 12 times y minus 1 over 4, you will get canceling out there. 2y is greater than 4 times 2 plus y minus 3 times y minus 1. And then once you distribute, you'll have 2y is greater than 8 plus 4y minus 3y plus 3. And then if we combine everything on the right side, you will get y plus 11. I'm going to move this y over, and now I have y is greater than 11. So then the way that will look like on a number line. So y is greater than 11. The way that will look like on our number line will be, if we slap an 11 right here, it will be everything greater than 11, but it will not include 11. So something like that parenthesis, and I will write this in interval notation as well. It will go from 11 all the way to infinity, but since it doesn't equal 11, it's a parenthesis, and on this top one, it'll go from negative infinity all the way up to 27, and it does include 27, so it's in a bracket. Alrighty, now on to number 28. It says, given A is this set of 2, 4, 6, 8, and 10, and B is equal to the set of 0, 3, 6, and 9, find A union B. So to find the union, all union means is everything in either or sets. So that will actually include for us every number in both sets. So 2, 4, 6, 8, 10, 0, 3, and then the 6 repeats. I'm not going to write it again. 9. And then typically you'd want to write this in ascending order. So we'd start with 0, 2, 3, 4, 6, 8, 9, and 10. So that is our answer. Now for this next one is asking, find the intersection between A and B. and that means the numbers that are in one and in the other. So it's the numbers that will match. So if we look at both of these, the only number that matches in both of them is 6. So our answer for that will be just 6 in the little squiggly brackets. All right, now on to number 29. Solve the following compound inequalities. Graph the solution set and write the solution set in interval notation. So for this first one, I'm going to work it out. Over here on the left. So we'll do A of number 29. It says negative 2 is less than or equal to 4 minus x over 3 is greater than 6. So you can solve this one of two ways. You can break it up into two inequalities like so. Or you can leave it all together and then just make sure you do what you do to the middle to both sides. But I'm going to have it broken up like this. So to start this one on the left, I'm going to multiply everything through by 3 to get rid of this 3 in the denominator. And I'll have negative 6 is less than or equal to 4 minus x. And then I'm going to subtract that 4. Now I have 10 is less than or equal to negative x. And then if I want just x, and then remember to switch the sign, so you have x is less than or equal to our 10. And we got to find it for the other side. So same idea, multiply through by 3, cancel out, 4 minus x is greater than this 18. And then I'm going to subtract this 4. Negative x is less than 14. And then I'm going to get rid of that negative, switch that sign. X is greater than a negative 14. So now if we want to have a combined answer, it'll look something like, oops, sorry about that. It'll look something like this. X is less than or equal to our 10, but it is greater than, just greater than, a negative 14. Or you can have it switched so it's in ascending order and say negative 14 is less than our x, which is less than or equal to our 10. And that in interval notation looks like it goes to a negative 14, but it doesn't touch it, which is why it's a parenthesis, and then up to a 10, and it can't equal that, so that's a bracket. And then if we were to graph this on a number line, we'd slap a negative 14 right here, slap a positive 10 here, and then, since it cannot be a negative 14, it'd be an open circle or a parenthesis, but since it is 10, it'd be a closed circle or a bracket, and it's everything in between those two. All right, so now for the next one, for B, it says negative 4/3 y is less than 24, or y plus 7 is less than or equal to 2y minus 3. So when you have or, if you have two distinguishing sets of answers, you will use the union symbol. Otherwise, you'll just merge your answer. So for this very first one, we will divide through by this negative 4/3. So y is, and since it was negative, we got to flip that sign. Y is negative 24, and then that's the same as multiplying by the reciprocal. So that would be 6. So y is greater than 18. Or, and then we do the same thing over here, get all the y's together and all the numbers together. So we have 10 is less than or equal to this y. So that is our or answer. So then if we were to write that in notation, it will look just like that basically. Y is greater than 18, or y is greater than or equal to 10. And if we were to graph that on a number line, I'm going to skip over the set notation real quick just to show y'all something. If we were to graph this on a number line, we would have 10 and we would have 18. And it can equal 10, so that would be a bracket. And it's everything to the right of it, which includes that 18. So when we write this in interval, because it's an or, we would say something along the lines of from 10, in a bracket, all the way to positive infinity in a parenthesis. All right, and then the last one should be a similar process. I'm going to make this a little bit smaller. Just to move this out of the way. Okay, and now I'm going to go ahead and work on C. So C is negative 2, x minus 1 plus 4 is less than x plus 3. And this 5x plus 2 minus 3 is less than 4x plus 1. So let's go ahead and solve this. So that would be, if we distribute it through, negative 2x plus 2 plus 4 is less than x plus 3. And distribute this through 10x, oh no, not 10, 5x plus 10 minus 3 is less than 4x plus 1. So now if we combine like terms here, I'm going to move this over. And then all these will be grouped together, and all of this will be grouped together. So we have 2 plus 4 minus 3, which is 6 minus 3, which is just 3, is less than x plus 2x, which is 3x, divided by 3. We get 1 is less than x, or x is greater than 1. And over here I'm going to do the same thing. So I'm going to move that 1 over, and then move that 5x over. These will all be grouped together, and this will all be grouped together. So it'll be 10 minus 3 minus 1, so it's 7 minus 1 is 6, is less than a negative x. And then if we want to get rid of that negative, remember the sign switches, so now we have a negative 6 is greater than x, or x is less than negative 6. Now if we write that in terms of interval notation, so it looks like that, right? But if we were to draw a number line here, just going to show you real quick, and we slap a negative 6 here and a positive 1 here, and we start graphing it. So it has to be everything less than or equal to the 6, so parenthesis, or anything greater than this positive 1, correct? Since our question said and the 2, we want to look for where things overlap. And since there is no overlap for this specific problem, we would just say there is an empty set. So just the squiggly brackets with nothing in them. Okay, now for number 30, I'm going to move this over to the side just a little bit. We are going to, so it says, the months of June, July, August, and September are the wettest months in Miami, Florida, averaging 7.83 inches a month. If Miami gets 8.54 inches in June, 5.79 inches in July, and 8.63 inches in August, how much rain is needed in September to exceed the monthly average for those 4 months? So we start by visualizing. So we know that this average is 7.83 inches in 1 month. Or it's just an average, right? So the sum of all inches divided by the sum of all months. And you want your average for the inches given to exceed the monthly average. So you want the average on this right side to be greater than the 7.83 inches a month. So if we get 8.54 inches in 1 month and 5.79 inches in the other month, and then 8.63 inches in the third month, you want to find what inches in the fourth month, and then if we divide it by 4 total months to exceed that 7.83. So it'll look something like 7.83 is less than, and then if we add all those up, 8.54, 5.79, and 8.63, we get this 22.96 plus x over 4. And then from there, it's just an inequality like we're used to from the other problems. Multiply through by this 4 to get rid of it here. And then we will have a 31.32 on this side is less than 22.96 plus x. And then if we get rid of this 22.96, we will be left with 8.36 is less than x. So this means that our x has to be greater than, so the amount of rain that must be needed in September is that it's more than 8.36 inches. So we can write that here as x has to be greater than 8.36. And this means that there needs to be no more than 8.36 inches of rain in September. Or no, there needs to be more than 8.36, no less than 8.36. So I'm going to write this in words.
Okay, so for number 31, we have to solve the absolute value equation. -2 times the absolute value of 3y minus 10 plus 4 equals -6. So the first thing I'm going to do, I'll write over on the left, oops, missed some of the stuff I was erasing, is, well, first I'm going to rewrite the equation. That's highlighter. Okay. -2, absolute value of 3y minus 10 plus 4 equals -6. So first thing I'm going to do is I'm going to bring this plus 4 over. The idea is I'm trying to get this absolute value term by itself. So first thing I do is I bring that 4 over. Now I'm going to divide by the -2. So now I have the absolute value thing on its own. It's going to equal +5 because -10 divided by -2. Now for this inside the absolute value can either be positive or negative. So there's going to be two different cases. There's going to be 3y minus 10 is going to equal +5. That's a really straightforward one, right? Or this inside could be equal to -5, and the absolute value of -5 is +5. So those are our two different cases, and we got to solve for each of these individually. So I'll add 10. So 3y equals 15. Y would have to be 5. Here I'll add 10, so I get 3y equals 5. And so I get y is going to be 5 over 3. So those are my equations. My answers are y equals 5, y equals 5/3. So for this next one, we need to solve the absolute value inequality. 6 times the absolute value of 2x plus 3 is less than or equal to 30. We're going to have to graph the solution set and write the solution set in interval notation. So the first thing I'm going to do is I'm going to divide both of these sides by 6. So we'll get absolute value of 2x plus 3 is less than or equal to 5. Now when I undo the absolute value, what's going to happen is, because this is less than the absolute value is less than this number, I kind of think like it's going to be stuck inside of this 5. But when you undo the absolute value, it's going to have to be stuck inside the 5 in the -5. So this is what we're going to get. If this was the other way around, then we'd have an OR statement where we have two separate inequalities we have to solve for. But because this is less than the number, the absolute value is less than the number, that means it's an AND, which means it's going to be in the middle. It's like one big inequality that we can solve for. And from here, we can subtract 3 from both sides. We get -8 is less than or equal to 2x. which is less than or equal to 2. Then we divide everything by 2. Minus 4 is less than or equal to x, which is less than or equal to 1. And if we want to, we can check this. We can take any of these, minus 4, 1, anything in between, and plug into the original one, and it should work out, right? So if 0 is in the middle, 2 times 0 is 0. 0 plus 3 is 3. 6 times the absolute value of 3, which absolute value of positive 3 is 3. 6 times 3 is 18. That's less than or equal to 30. It checks out. So we solved it. We need to graph the solution set and write the solution set in interval notation. So I'm going to try. Okay. Also, I'm going to do the thing that would make the line straight for me, but that's okay. Draw our number line. So I'll put minus 4, and I'll put 1. Minus 4 and 1 are included, so I'll put dots. In my interval, it's everything in between, because that's where my x's are. They're in between minus 4 and 1. So there's that. And then for interval notation, it's going to be minus 4 in a bracket, because we're including the minus 4, 1. Also in a bracket, because we're including that as well. Okay, next step, we're going to solve the absolute value inequality. Absolute value of 3x plus 5 minus 4 is greater than 11. So first thing I'm going to do is I'm going to move that minus 4 over, so we get absolute value of 3x plus 5 has to be greater than 15. So whenever we undo this absolute value, because it's greater than the number, we're going to get an or statement, right? So that means that our first statement is going to be 3x plus 5 has to be greater than 15. It's just the straightforward one. We don't change anything. We just drop absolute values. Or, and this is the trickier one, 3x plus 5. We got to switch the sign, and we switch the sign on the 15. So we flip the direction of the inequality, and we switch the sign. Because, for example, if we get on the inside of this, if that was negative 16, right, a number that's less than negative 15, absolute value of negative 16 is positive 16. Positive 16 is bigger than 15, so that would work. So any number that's less than negative 15 will work, or any number that's bigger than 15 will work. So we're going to solve each of these individually. So I'll go ahead and I'll say 3x is going to be greater than 10. X has to be greater than 10/3. Over here, we'll get 3x is going to be less than negative 20. So x is going to be less than negative 20 over 3. So when we go ahead and I'll graph the solution, I have minus 20 over 3, and over here we'll have 10/3. So what's going on? Well, because we have this or, we just have to meet either one of these conditions, right? So it means we put a circle here because we're not including 10 over 3. That or anything above it works. That's what this first one is saying. Put another circle on negative 20 over 3 because we're not including that one either. That or anything below it works. That's what the second term is saying. So we have this or that. We have this side or that side. So that's graphing it. And then to write the solution set in interval notation, well, it's going to be every number less than negative 20 over 3. So we're going to start at negative infinity. We're going to go all the way up to negative 20 over 3. We're not going to include it, so it's a parentheses. Now we're going to use our union, because we're going to have another set of numbers. What's the other set? Well, it's everything bigger than 10 over 3. So it's going to be 10 over 3, comma, infinity. And that is our answer in interval notation. We've graphed it, so that's all we have to do for that one. So for question number 34, the last one, we've made it. A box of cereal is labeled to contain 16 ounces. A consumer group takes a sample of 50 boxes and measures the contents of each box. The individual content of each box differs slightly from 16 ounces, but by no more than 0.5 ounces. If X is the exact weight of the contents of a cereal box, write an absolute value that inequality that represents an interval in which to estimate X. So here is what we're going to write. I'm going to write it down here because there's not much space to write it actually under there. So part A. So So we're trying to estimate x, right? And we want to get an absolute value interval. So the idea is, because if x is the real way of the box, if x is the real way of the box, and it should be 16, so it means that x minus 16, that's the difference between the actual and what it should be. Well, how big can that difference be? Well, it can't be bigger than 0.5. So it means the absolute value of the difference cannot be 0.5, right? Maybe this one's bigger than that, or that, maybe it's a little bit more than 16, maybe it's a little bit less than 16, but the absolute value, the difference, right, just the pure, like, how far off you are, has to be less than 0.5. So that's kind of where we get that. So part B is to solve that and interpret the answer. So for this, we're going to go ahead, because this is less than the number, that means that when we set it up, this is an and, so we're going to have our compound inequality of negative 0.5, it's going to be less than or equal to x minus 16, which is less than or equal to 0.5. From here, we just add 16 to both sides. We get 15.5, which is less than or equal to x, which is less than or equal to 16.5, which makes sense. The actual weight is going to be within 0.5 of 16, but it can be on either side. So that's 0.5 less and 0.5 more. So, to put in a sentence, the boxes of cereal I'll say vary in weight, or you can probably use the word differ. I don't think the exact wordings matter. From 15.5 ounces to 16.5 ounces. I guess I'll say including both. So sometimes, like, you might see the word inclusive or something that's just saying, like, you can't be 15.5, you can be 16.5. So there's that. That's the end of the review. Thanks for watching. We'll post more of these later on in the semesters before the other exams, so, watch out for those. They'll be on the website. You can, I guess, subscribe. I don't know, we're not really going for subscribers, but, go ahead and hit the subscribe, hit the bell icon, I guess, if you want to be notified next time we do a math review video. But, yeah, thank you.